everyone, so today we are going to be identifying families of functions and describing and graphing transformations of the absolute value parent function. Before we get started with the new content, let's just do a warm-up to get our brains working. We want to graph the following equations, find the x-intercept, and find the y-intercept. So I'm going to zoom in on this guy. Really, this is 2x plus 0. That means that my slope is equal to 2, and my y-intercept is 0, 0. So I'll graph 0, 0, and from there go up 2 over 1, up 2 over 1, and then we can just really draw our line through those points. Okay, so I already know the y-intercept, right? The b value is the y-intercept, 0, 0. I also know it's the y-intercept because that's where the line crosses the y-axis. And what would be the x-intercept? Just looking at what point crosses the x-axis. 0, 0 is where it crosses the x-axis. So my x-intercept is also going to be 0, 0. Okay, looking over here, I get a 3x plus 1. It has a slope of -3 and a y-intercept of 0, 1. So I've already plotted 0, 1. From there, we're going to go down 3 over 1. So we start on our y-intercept, go down 3, and then right 1. Then from that point, down 3 and right 1. Okay, we can connect those points to form a line. My line's a little bit off. This is easier to do on paper if you have paper and a straight edge. Okay, so I already know that my y-intercept is 0, 1, just because that was my b value. What about the x-intercept? What would that be? Where does it cross the x-axis? At this point right here, right? But what is that point? I mean, we could estimate it, but we wouldn't have an exact answer. So how do I find the x-intercept? Where do I plug in 0? I plug in 0 for y, and then I solve for x. So I'd subtract 1 on both sides, divide both sides by -3. So I get that 1/3 is equal to x. So my x-intercept is going to be at 1/3. You can't really read that. Let me rewrite the 1/3. 1/3 comma 0. Okay, and it looks like that point is at about 1/3. All right, now that our brains are warmed up, let's go ahead and start talking about identifying function families. Function families are functions that share key characteristics. So functions that belong to the same family share key characteristics. They kind of look the same. The parent function is the most basic function in a family. Okay, we're going to be transforming the parent functions to create other functions in the same family. So we've already talked about the parent function for lines, right? That's just y equals x. We talked about how it's got a point at the origin, and you go up 1 over 1, up 1 over 1, up 1 over 1, right? It has a slope of 1. We've also already introduced the absolute value parent function. Absolute value, every function in that family is going to have a V shape. Okay, we start at the origin again. Again, it's up 1 over 1, up 1 over 1, up 1 over 1. This side has a slope of 1, right, where it's up 1 over 1. And this side has a slope of -1. Okay. Quadratics, I'm not going to worry too much about that right now. We'll get to that later. But all of the functions in the quadratic family have a U shape. Okay, so that's the most important part of this graphic, is just knowing what the general shapes of each function family are. If I tell you we're graphing a line, it just is a straight line. If I'm telling you we're graphing an absolute value equation, you should immediately think V shape. If I tell you we're graphing a quadratic function, you should be thinking U shape. Okay, memorize those shapes. Okay, so I'm going to put a big comment here to memorize shapes, right? The line, the V, and the U. Okay. You know it's a U shape when you see the squared. You know it's a V shape when you see the absolute value marks. And you know it's linear if you don't see either one, basically. So absolute value parent function. Remember, we can find parent points by just picking some x values to plug into y equals absolute value of x. So what happens when you plug in -2 into the absolute value bars? It becomes positive. What happens if you plug -1 into the absolute value bars? It becomes positive. Plug 0 in, 0. Plug 1 in, 1. Plug 2 in, you get 2. Okay, and if you graph all those points, it forms a V shape. Here's the point -2, 2. Here's the point -1, 1, 0, 0, 1, 1, 2, 2. It forms our V shape. Again, you want to memorize the key points of your parent function, because what we're going to be doing is transforming it. We've already introduced some of the vertical transformations in the last lesson. So vertical transformations, we talked about what a vertical reflection looks like, right? That's when you see the negative out front. We already talked about vertical stretch and vertical shrink, right? It's going to stretch if your number out front is bigger than 1, where it's going to shrink if that number is less than 1 but bigger than 0 in front of x. Okay, and then translation up or down, we've already talked about that vertical transformation. The only new transformation we're going to add in today is this horizontal transformation, left or right units. Okay, and all the horizontal transformations are kind of tricky because it's almost opposite of what you think. Okay, so what we're starting with here is the general form of any absolute value function. I know it's absolute value because I see those bars. Okay, so I instantly know it's going to be a V-shaped graph. If A, right here, is bigger than 1, that's going to cause a vertical stretch. So for example, if I have something that looks like this, 2 times the absolute value of x, it's going to cause a vertical stretch. If A is between 0 and 1, that's going to cause a vertical shrink. So like if I had y equals 1/2 times the absolute value of x, it would be a vertical shrink. If I had y equals 0.2 times the absolute value of x, again, that's a number less than 1 but bigger than 0 in front of the absolute value bars there. So that's going to be a vertical shrink. Now what happens if I see a negative out front? That's going to indicate a vertical reflection, or a reflection in the x-axis. Okay, I can put in x-axis. Okay, so a vertical reflection is a reflection over the x-axis. So an example of that might be like negative absolute value of x. Okay, then we move on to the inside. We have x plus h and x minus h. This part is the new part. Okay, so that's going to be our horizontal shift left or right. If you see x plus h, what do you think is going to happen? Typically, you would think that it would move to the right, but actually it's going to be a translation to the left. Okay, so like if I see something that looks like this inside the absolute value bars, x plus 3, that's actually going to be left 3, which is weird. You'd almost think it's right 3. So if I see x minus h, that's going to indicate a translation to the right. So for example, if I see something like this, absolute value of x minus 2, that would be right 2. It's just kind of weird. Okay, it's almost opposite of what you think. Then plus k and minus k out back. That's similar to when we talked about linear functions. That's going to be your up-down shift, and that's exactly what you think. Vertical translation up, and minus k is going to be a vertical translation or slide down. So if I see something like y equals absolute value of x plus 3, that's going to be up 3. And y equals absolute value of x minus 2, that's going to be down 2. Notice the placement. In this last example here, the plus 3 and minus 2 were outside of the absolute value bars, whereas when we talked about horizontal translation, those values were inside the absolute value bars. Okay, I want you to make a note of that anything outside the absolute value bars is vertical transformations, and anything inside is horizontal. So like this would be vertical, this would be horizontal, this would be vertical. Okay, anything inside, horizontal, anything outside, vertical. Remember, inside absolute value or parentheses indicates what? Is it horizontal or vertical? It's going to be horizontal change or horizontal transformation. And anything outside the absolute value or outside parentheses is going to be a vertical transformation. Remember, horizontal transformations, anything horizontal moves left to right, that's going to change your x values, whereas anything vertical is up-down change, so that's going to change your y values because it's a change on the y-axis. So in example 1, we're just going to describe the transformation. It says use the vocab word bank to compare the graph to the graph of its parent function. So remember, the parent function has a point at the origin. We can go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 back 1, up 1 back 1, up 1 back 1. This is what the parent function looks like. Tell me some key changes that you see. Tell me about the width of the graph. Is it getting wider, more narrow, staying the same? Number 1 is that the graph from the parent function to the given function is getting more, hold on, my little cursor isn't working. What's going on? Okay, so in example 1, we're going to be describing the transformations. It says use the vocabulary word bank to compare the graph of f to the graph of its parent function. So let's just start by graphing the parent function. The parent function has a point at the origin, and then you can go up 1 over 1, up 1 over 1, up 1 over 1, up 1 back 1, up 1 back 1, right? That side has a -1 slope. Okay. Tell me what happened to get from the red graph to the blue graph. What's the first thing that happened? Let's talk about the width. Did the width get wider or more narrow, moving from red to blue? The graph narrows, right? And then what's another thing that happens? What happens to the point at the origin? It moves up, right? And then there's going to be a translation up. Okay, so let's be a little bit more specific. If I see a graph narrow, what kind of transformation is that? Let's look at our vertical transformations. Here I see the word narrows. So that's going to be a vertical stretch when it narrows. Okay, so vertical stretch. Do you see how there's a 2 outside of that absolute value? Right, it's right in front. That tells us the scale factor. Okay, so it's going to be a vertical stretch by 2. And then how many units would we move up? What does the +1 tell you? That tells you how many units it moved up. So I'm going to say vertical translation up 1. Okay. So just to recap, remember a vertical reflection is a reflection on the x-axis. It says circle the part of the function that indicates a vertical reflection. So that's going to be this part right in the very front. If there's a negative there, then that indicates a vertical reflection. It says a vertical reflection is a transformation that flips the graph over a horizontal line called the line of reflection. A reflected point is the same distance from the line of reflection as the original point, but on the opposite side of the line. Okay, anytime we have a vertical reflection, because it's vertical, we know that that changes the y values, and you're just going to multiply all the y values by -1. For vertical stretches and shrink, it says circle the part of the function that indicates a vertical stretch or shrink. That's going to be the a value. Okay. Remember, if a is bigger than 1, it's a stretch, and if a is between 0 and 1, it's a shrink. It says multiplying the y coordinates by a scale factor greater than 1 causes a vertical stretch, which narrows the graph, and multiplying the y coordinates by a scale factor greater than 0 and less than 1 causes a vertical shrink, which widens the graph. So you can see this over here, this picture to the right. See how we have y equals 3x? 3 is a number bigger than 1. That causes a vertical stretch, which narrows the graph. Versus here in the green, we have 0.5 times the absolute value of x. That's a number less than 1, but bigger than 0. So that's going to be a vertical shrink. See how wide that graph is? Okay, so narrows, stretch. Widens, shrink. Okay, anytime you have a vertical stretch or shrink, again, you see that word vertical there. Think about the vertical axis. That's the y-axis. What you're going to do to change the y values is just multiply them by whatever a is. Okay. So looking at this, it says graph the parent function, graph the given function, and show work using the xy chart. Describe the transformations. So let's go ahead and start by graphing the parent function. I'm going to do the parent function in red, plot the origin. We go up 1 over 1, up 1 over 1, up 1 over 1, up 1 back 1, up 1 back 1, up 1 back 1. Okay, that's my parent function. And the key points we want to use for the parent function, absolute value of x, would be what? What happens when you take the absolute value? Like if I plug -2 in, you'd get +2. If I plug in -1, what do I get? +1. Okay, keep doing that. Plug in 0, plug in 1, plug in 2. All of your values should be positive. Okay, so that's the parent function. That's what you memorize. How is the new function different? What transformation has occurred? 1/4 is in front of the absolute value of x. So let's go back up here. 1/4 is right here in front. It's our a value. If a is between 0 and 1, then what happens? A vertical shrink. Okay. So this would indicate a vertical shrink by 1/4. Okay. And what do I do? Like, let's go to where it says vertical stretches and shrinks. If I have a number out front and I see a vertical shrink, then I'm going to multiply the y values by whatever that a value is. Okay, note we're multiplying the y values. These are the y values because it says the word vertical. So I'm going to multiply all the y values by 1/4. 2 times 1/4 is what? 2 times 1/4 is 2 over 4, which reduces to 1/2. 1 times 1/4 would be 1/4. 0 times 1/4 would be 0. 1 times 1/4 is 1/4. And 2 times 1/4, again, 2 times 1/4 would give you 2/4, which reduces to 1/2. So all of these y values I just changed. I transformed the function and got new y values. So I'm going to plot the point negative 2, 1/2 first. So negative 2, 1/2 would be right here. Then I'm going to plot the point negative 1, 1/4. Negative 1, 1/4. It should be even closer. Oh my goodness, it's going to be so close. And then I'm going to plot the point 0, 0. Okay. Then I'm going to plot the point 1, 1/4. Really close to the x-axis there, and then 2, 1/2. So it'll look like this. Now look what happened to our graph. What happened? Do you see how it got wider? That should happen when I'm vertically shrinking. You want to think about it like you take your foot and you stomp on that red graph to shrink it down, right? Like if you've ever done that with a can of Coke or something and you stomp on it, it's going to widen it. It's going to get flat, right? It's going to flatten out. What about this guy? This one actually has two transformations. See, I have the negative and the 2. What does the negative do to your graph? That's going to be a vertical reflection, right, with the negative out front, or you can say a reflection in the x-axis or over the x-axis. Okay, what's the 2 do? Think of that as a separate transformation from the negative. 2, the number 2, is bigger than 1, so that's going to be a vertical stretch by 2. Okay, so this is actually a combination of transformations. Okay, let's write our parent function first. We always start with our parent function, right? If I plugged in these x values to our absolute value sign, they would all become positive. Okay, let me graph those over here. We have negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. That's our parent function. And now we're going to graph the transform function, which I'll do in blue. Okay, the first thing I want to take care of is the vertical reflection. What do? I take all my y values, right, because it's vertical. That indicates y values. And I multiply them by what? What do I multiply the y values by? Let's go back to where it says vertical reflection. Right, vertical reflection. If I have a vertical reflection, I need to multiply the y values by negative 1 in order to get them to flip. Okay, so 2 times negative 1 is negative 2. 1 times negative 1 is negative 1. 0 times anything is 0. 1 times negative 1 is negative 1. And 2 times negative 1 is negative 2. So this is my vertical reflection. Okay, and then what do I do in order to do the vertical stretch by 2? Again, it says the word vertical, so I know I'm changing my y values. So all these y values are going to change again a second time. And I'm going to multiply them by 2 because that's the scale factor. So this will become negative 4. Negative 1 times 2 is negative 2. 0 times 2 is 0. Negative 1 times 2 is negative 2. And negative 2 times 2 is negative 4. So those are all my new y values. This was from the vertical stretch. Okay, let's plot those. I have the point negative 2, negative 4. Okay, negative 2, negative 4. I have the point negative 1, negative 2. Okay, grab that. I have the point 0, 0. I have the point 1, negative 2. And I have the point 2, negative 4. All right. Now, what happened to the graph? Well, we notice it flips upside down, so that's from our vertical reflection. And do you see how it got more narrow? It got more narrow because of the vertical stretch.